Good morning. Today we are going to talk about how we divide with large numbers, such as 2-digit and maybe even 3-digit numbers. Now, this process follows the same main steps as long division, so I'm going to write those steps out for a minute. We have our divide, we have our multiply, we have our subtract, and we have our bring down. These are the 4 main steps that we want to be doing as we go through our question. And so I'm just going to show you how I do that, especially with numbers that are really, really big. So the first thing that I do is I look at how many times 72 fits into the first 2 digits over here. Now 72 fits into 14 absolutely 0 times. That does not fit at all. So if I recognize that this number doesn't fit into the 2-digit number, I put a 0 up there, and then immediately I go to looking at the first 3 digits here. Now I have to figure out how many times 72 fits into 144. Now both of those numbers are super big, and that is not an easy thing to do in my head. So what I do is I estimate, and I estimate by covering up the last digit in each number. So instead of trying to fit 72 into 144, I fit 7 into 14. And I know that 7 fits into 14 twice. So above there I put a 2. Fits in 2 times. There we go. That is our divide step. We figured how many times it fits in. So next we go to our multiply step. We're going to multiply this number up here by the 72. So I can do that off on the side. And with these you are going to have to do some long multiplication work as well. So here we go. 72 times 2. 2 times 2 gives me 4. 2 times 7 gives me 144. And look at that. It fits in exactly. That does not happen often, but in this case it did. How nice. So then what I'm going to do is I'm going to take that number and I'm going to subtract it from the number that I have. So 144 minus 144 gives me 0. And then I go to my bring down stage where I bring down the next number. Now in this case, I think 72 fits into 8 0 times. So once again, I'm going to have to write a 0 up here. But now that we're actually in our question, we're actually going to have to follow all of our steps. So it fits in 0, that's our divide step. Then we multiply. 72 times 0 gives me 0. Then I do my subtract step. 8 minus 0 gives me 8. And then I go to my bring down step. Except look. Excuse me. There's not another number to bring down. So that means that I have found my answer, and whatever number I have here is just my remainder. Now I check 1 second to make sure my remainder is smaller than 72, the number I'm dividing by. And if that is the case, I can write my remainder out. Now I can write my remainder 2 ways. The question will usually specify which way it wants. The first way I could write it is just as a remainder 8, like that. I could also write that remainder as a fraction by doing 8 over 72. And then I just want to see if I could reduce that fraction as I go. So for example, both of these fit into the 2's. So I'm going to divide by 2. I get 4 over 36. And looks like that is going to reduce again. So I get 2 over 15, 16, 17, 18. And then it reduces even farther to 1/9. Now, if I was smart, I might have seen that 72 is the same thing as 8 times 9. I could have reduced it like that to begin with, but sometimes Miss Freeman doesn't have all the answers. So there we go. My remainder is 1/9. So then the answer to this question, I'm going to put it in this circle over here, is 20 and 1/9. There we go. That is how we long divide. Now this one was nice because we didn't have to do a lot of multiplying. Sometimes they can be a little bit trickier. So I'm going to look at the next one. So this next one looks a little bit like this. And once again, I'm going to write out all my division steps because I follow the same division steps, whether it be a small division question or a large one. So I have my divide, I have my multiply, I have my subtract, and I have my bring down. Now, as I look at this 69 here, I'm also going to do something I like to call rounding. I notice that 69 is very close to 70. And if I treat this number like a 70, I'm going to have less trial and error than if I treated it like a 60. So I'm just going to keep that in mind as I do my divide step, and only my divide step. I only think about the estimate during that first divide step. So for example, I'm going to look at this and I'm going to think, how many times does 70 fit into 27? 70 is bigger than 27, so it can't fit in. I put a 0 up there and I move to looking at my first 3 numbers. How many times does 70 fit into 273? And this is where I do my other estimating work. I take one number off this one number off this one, and I think, how many times does 7 fit into 27? 7 fits into 27 3 times, because 3 times 7 gives me 21. So now that I have my number up there, I do my long multiplication. So when I multiply, I don't use the 70, I use the original number, the 69. So that's what I'm going to do. 69 times 3. 9 times 3 gives me 27. 6 times 3 gives me 18, 19, 20. I get 207, which seems pretty close to that number there, but let's see what happens when we subtract them. So I'm going to minus 207 from 273. 3 minus 7, I can't do it, so I borrow. 13 minus 7, that gives me 6. 6 minus 0 gives me 6. 2 minus 2 gives me 0. So I have 66 down there. And just before I move on, I'm going to check, is 66 smaller than 69? Why, yes it is. Now, if this number was bigger than 69, we'd know that it actually fit in 4 times, and we'd have to do our multiplication again to figure out how many times it fits. But because it's smaller than 69, we are good to go. We can move on to our next step. So we divided, we multiplied, we subtract. Now we have to bring down, and I do have a 1 that needs to be brought down here. There we go. So then I'm now going to be thinking about how many times 69, or a rounded 70, fits into 661. So once again, I estimate. I cover up my last number here. I cover up my last number on the 70 there. 7 fits into 66 9 times, because 7 times 9 gives me 63. So now that I have my number, I move on to my multiply. Once again, I multiply with my original number, so I do 69, and I times it by the newest number that I just found, by the 9. 9 times 9 gives me 81, 9 times 6 gives me 54, plus 8 is going to give me 55, 56, 57, 58, 59, 60, 61, 62, 62. So I get 621. Oop, and it looks like this is going to be good, because when I subtract that, I'm probably going to get a number smaller than 69. Let's just check it out, though, to make sure. So moving on to the subtract stage. Here we go. We're going to do 661 minus 621, getting that from down here. And off we go. 1 minus 1 gives me 0. 6 minus 2 gives me 4. And 6 minus 6 gives me 0. So I have 40 left over. I look to see if I can bring anything else down, but nope, there's no number there. That means that I'm at the end of my question, and my remainder is 40. So once again, I write that remainder one of 2 ways. I either write it R40, or I can write it as 40 over 69 and reduce. In this case, I don't think those numbers will reduce, so I can leave it just like that. And there we go. That is how we long divide. It does take a while. There is a lot of steps. Your kids might need some help remembering where they should go next. Sometimes they forget which stage they're at. And sometimes they need a bit more space to do these questions as well. If you notice, even the space I'm taking up on my page here is a lot bigger than the space given in their textbooks. So just be careful with that. You might want to write out the question on lined paper to help them out with it. Thank you very much for listening. All the best.